Okay, in this video we're going to be looking at parametric equations. So we'll start off with the definition of parametric equations. If x and y are continuous functions of variable t on an interval I, then the equations x equals x of t and y equals y of t are called parametric equations, and t is called the parameter. The set of all points x, y obtained as t varies over the interval I is called the graph of the parametric equations. The graph of a parametric equations is called the parametric curve or plane curve, denoted by C. And so some functions are better represented as parametric equations than they are in a regular rectangular form, and it may be easier to do things in parametric form. So let's do a couple examples of graphing things in parametric form, and then we'll try to eliminate the parameter. So first example here, we're going to sketch and eliminate the parameter. And our set of parametric equations is x is going to be equal to 2t plus 4, and y is equal to t minus 1. So what we're going to do is we're going to pick a couple of t values just to kind of get an idea of what's going on. So we're going to pick numbers close to 0. So we're going to do minus 2, minus 1, 0, 1, and 2 for t. And then we have our x is equal to 2t plus 4. And then we'll just plug in those t values. So t is negative 2, so we got 0 for the x value. Just plug those in, 0, 2, 4, 6, and 8. And then we'll plug in for the y's. So y is t minus 1, so we'll get negative 3, negative 2, negative 1, 0, and 1. So you got to be a little bit careful when you're graphing the x and the y, so you're not going to be graphing t here. Okay, so our first ordered pair is going to be 0 and negative 3. And then our next ordered pair is going to be 2 and negative 2. And then the next one is 4 and minus 1, 6 and 0, and then finally 8 and 1. Okay, and it appears to be that they form a line, and then we also have an induced direction. So when we do a parametric equations, we'll have a direction, and so as we plotted the points, we were going from left to right, so that gives us the induced order from left to right there. Okay, now if we want to eliminate the parameter, we need to solve the equation, one of the equations for t. I'm going to solve x equals 2t plus 4. I'm going to solve that for t. So I'm going to subtract 4 and divide by 2. Okay, and that's going to be equal to t. Now I'm going to substitute that into y equals t minus 1 for the t. So y is equal to x minus 4 over 2 minus 1, or y is equal to 1/2 x minus 3. And that's just an equation of a line with a y-intercept of negative 3 and a slope of 1 over 2, which seems pretty consistent with our picture there. Okay, all right, let's do another example or two. So number 2, we're going to do the same thing. We're going to sketch the graph, and then we're also going to eliminate the parameter. So x is going to be equal to cosine of t, y is equal to the sine of t, where t is going to be in the interval 0 to 2 pi. Okay, including 0 and stopping at 2 pi. We're going to go ahead and make a table, and because we're dealing with the sine and the cosine, we're going to use the nice values on our trig circle. We're going to use the poles. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then we're going to find the cosine of each one of those values, which would be 1, 0, minus 1, 0, and 1. And then we'll find the sine of each one of those values, which is going to be 0, 1, 0, minus 1, and 0. Okay, so we're going to start off drawing that in, and let's see, let's go ahead and graph both the cosine and the sine how we normally would in rectangular coordinates. And so here's the cosine graph. Okay, and then we'll also graph the sine how we normally would. So here's the sine wave. Okay, Alright, now let's draw our parametric equations curve. So the first point is going to be 1 and 0. It looks like we might be eliminating the parameter here first. So using the Pythagorean identity, cosine squared plus sine squared, it's equal to 1. Okay, so cosine is x, sine is y, so we have x squared plus y squared is equal to 1, and that is going to be our unit circle centered at the origin. So we actually have a circle, so there is our circle there, and we do have an induced order, so we would start out at 1, 0, and then we'd go to 0, 1, and then minus 1, 0, and then 0, minus 1, and so we have a counterclockwise rotation there. Okay. Later on, when we get into polar coordinate system is going to be very similar to what we have right here in terms of what our x and our y is. So dealing with circles, for example, is going to be easier to do in polar coordinates. All right, we got one more here. So we're going to look at x is equal to 6 sine of 2 theta, and y is equal to 4 cosine of 2 theta. This time our parameter is theta instead of t, and then when we get into polar coordinates, which is a special parameterization, you'll use the variable t as your parameter instead of theta. Sorry, I said that backwards. You'll use theta instead of t. Okay, now I'm going to graph this, but my argument's not theta anymore, it's 2 theta, and I want that to equal the poles. The poles mean 0, pi over 2, pi, 3 pi over 2, and 2 pi. So if I divide everything by 2, I have 0, pi over 4, pi over 2, 3 pi over 4, and 2 pi over 2, which is just going to be pi. So we'll construct our table using those new values. Okay, and x is equal to 6 sine of 2 theta. So we'll go ahead and evaluate. So that's going to be 0, 6, 0, minus 6, and 0. And evaluate the 4 cosine of 2 theta at those values, which will give us 4, 0, minus 4, 0, and 4. If we want to draw a rough sketch of this, here's what our x-coordinate is doing. It is the 6 sine of 2 theta. Okay, so we have a vertical stretch and a horizontal compression going on with the sine wave. And we'll also look at the y, which is the 4 cosine of 2 theta, which will also have a vertical stretch and a horizontal compression. So there we are. So the compression, instead of taking 2 pi to complete a full cycle, it has now been condensed down to completing a full cycle of pi. And normally the max and min for sine and cosine are minus 1 and 1. These have now been stretched to minus 4 and 4 and minus 6 and 6 respectively for the y and the x. Okay, so to do the graph, I'm thinking I'm going to go ahead and start labeling some stuff. So my y max is 4 and the y min is negative 4. And then the x max is 6 and the x min is minus 6. Okay. Now, if I solve for the sine of 2 theta, I would have x over 6, okay? I'm going to square that, so I get a sine squared of 2 theta. And then if I solve for the cosine would be y divided by 4, and then I'm going to square that. So x over 6 squared plus y over 4 squared, that's going to be the sine squared of 2 theta plus the cosine squared of 2 theta, and that's our Pythagorean identity, and so that's equal to 1. So we have x over 6 squared plus y over 4 squared is equal to 1, and that's an ellipse centered at the origin. The major axis is going to have a length of 2 times 6, which is 12, and the minor axis is going to have length of 8, 2 times 4. Okay, and we will also be going in the counterclockwise direction. So we have the first point of 0, 4, and hold on a second. I think we got a mistake here. Let's fix it. Okay. I believe we do have a mistake here. Okay, so we need to redo that, and I need to erase these arrows. So we may need to fix something here. All right, let's see. Starting out, we have 0 and 4, so we're up here. And then we're going to go to 6, 0. Okay, so it looks like we're going clockwise, and then 0, minus 4. And then minus 6, 0, and then back up to 0 and 4. So apologize, so we did have an error there, so we are actually going in the clockwise rotation. Okay. All right, I think there's going to be a second video for parametric equations, section 7.1, so stick around for that.